Hey guys, we're moving on. So I told you we're kind of done. We're done with some of those sine graphs. But the next problem on the exam is kind of asking you to understand graphs of different types. And some of them you already know. They're just seeing what you remember back from even Algebra 1. And then some we haven't got to yet, or some are going to be next year in pre-calc and stuff like that. But I'm going to just show you kind of some general graphs that you just want to be aware of. Now, the first one that we kind of know, I forgot to kind of say, but remember, y equals mx plus b. Remember, that's in that form. Remember, that's our slope, our y-intercept. Remember, that is called a linear equation. Linear, because, I mean, just like the word says, if I graph this, it makes a line. So again, there's no exponent. This is just a straight linear equation. So remember, we would start down at -3. Then our slope, remember, 2 over 1. So like up 2 over 1. I like to do it again, up 2 over 1. Okay, then this is going to be a straight line. So again, that's called a linear equation. So again, there's a question on the final exam. Now again, I don't know if I'll have time to actually do the final exam, but there's going to be a final exam that I could give you, and I'm trying to make sure you understand it all. Okay, now a couple of the ones that we just kind of got done doing was the sine graph. Now, the full name, but you wouldn't want to have this whole thing. Sinusoidal, it's kind of weird. Sinusoidal, Sinusoidal. So that is that wave graph. I mean, just like we've been doing. Okay, so that's a sinusoidal graph, a sine graph. Okay, that's just the way you say it. Now, some of you actually asked me, I remember before we left school, is there a tangent graph? Because obviously we did sine and cosine. We also did tangent. So this is actually the tangent graph. There are these asymptote dotted lines you're not allowed to cross. And it actually makes kind of a little wave in between these. So there's actually, so these red lines are the tangent graph. Now again, we'll get into this more in pre-calc, but that's the tangent graph. That's what that looks like. Okay. So again, that's kind of weird stuff. It's a multiple choice question. I mean, the exam has a multiple choice question on it. Okay. So that's kind of why I'm going over this. So they actually say, they give you a picture and say, which type of graph is it? Is it linear? Is it sinusoidal? Is it tangent? And then actually the answer is this one. And now if we were in school, we would do more. We'd grab the graphing calculators and use those, but obviously we don't have those at home. But you probably could go online and find some graphing calculator online stuff, type in these equations. Now obviously this is called exponential graphs because you can see the exponent is that variable. So when x is the exponent, it's called an exponential graph. Now, there's basically two types, and I'm just going to expose those to you, show those to you. It's not a huge deal. But when the base of the x is bigger than 1, a 2, a 4, anything, even a decimal, like 1.5. 1.5 is bigger than 1. This is an exponential growth. Now, you might have done a little bit of this in science class, exponential growth. I'm not sure if you would have done that in science class, exponential growth. But basically, any number that's bigger than 1 is going to start kind of growing slowly, but then take off and grow exponentially. Like a lot of times the populations of flies or mosquitoes, if they keep growing, they'll grow exponentially. Money If you put money in early on and never take it out of your account and it just sits there till you're 65, it grows exponentially. I mean, people have shown that you put $1,000 in when you're 18, leave it in there till you're 65, you might have close to $1 million because it's going to keep growing and then grow exponentially. Now, the second one here is a decay, which kind of makes sense. Growth or decay. Obviously, decay, see that base number is less than 1, 0.8. Anything less than 1, a fraction less than 1, a decimal less than 1 is an exponential decay. Okay, so the exponential decay, it just looks like the opposite of this. It's actually going to start high, and then it's going to decay down kind of to a flat exponential, just going to get kind of shorter, flatter and flatter. It never completely gets flat, but it just keeps decaying. Some of this stuff is like half-life of elements in science class. Like if you have 1,000 pounds of an element, at the beginning its half-life will go down to 500. Then half of that, 250, half of that is 125. But see, as it keeps getting half of something smaller, it's going to get flatter and flatter. It's not going to go down as fast because you're taking half of less. So again, this is an exponential decay. This one's an exponential growth. Again, back over there, we have a linear. Sinusoidal is just the sine graph, the wave, and then tangent is these red kind of zigzag things there. Okay, just like we've done before, again, it's kind of hard for you to actually do much. So just type in "got it," and I know that you saw the video, and soon we're going to have problems you can actually type in, okay? See you later. Bye.